All right, so let's look at another example. It says the data given in this table represent the age and systolic blood pressure for a sample of 12 randomly selected healthy adults. All right, so in this first column we have the age of our 12 people, and then we also have the blood pressure of our 12 people. So we're going to use this. So this is a table, but this could be given as a graph. We could do the exact same thing with a table or a graph. So in class, you actually may see a graph instead of a table. All right, so here's the first question. Suppose that X represents the age of an adult in years, and Y represents the systolic blood pressure in millimeters. I actually don't know what this stands for, mmHg. I'm sure you pre-med people know. Use the points 21, 118, and 51, 130 to write a linear model relating y as a function of x. Okay, so we're going to do the same thing. We're going to figure out, okay, what's our input, what's our output, what does x mean, what does y mean? All right, so we can use x and y as our variables. So x is our age in years. I'm going to write that down. And y represents the blood pressure in this unit of measurement. So I'm going to say it's the blood pressure. I could also come back here and just write it on my chart. So this is our x, this is our y. You got all that down. And it says use these 2 points to write a linear model relating x and y. All right, so remember, this is x comma y, so 21 is an age, 118 is a blood pressure. Matches what we said. 51 is an age, 130 is a blood pressure. All right, so how are we going to write a linear model? How are we going to write an equation of a line if this is all that we know? Well, we have 2 points, so that's part of what we need. We need a slope and a point to create a line. So we can find the slope from 2 points. All right, so how do we do that? Well, we just subtract the y values, divide and subtract the x values. 12 over 30. We can simplify this. I'm actually just going to use a calculator, and so we can just use decimals for this problem, because that's typically what you use in the real world, more than fractions. So this is 0.4. That's our slope. Okay, so we're one step closer to writing an equation of our line. Okay, so we have a slope. We have 2 points. We can use point slope to write an equation. You can choose whichever point you want. I'm going to use the 21, 118 to do it. So y minus my y value equals slope times x minus my x value. Okay. I'm going to distribute this 0.4. Okay, so 0.4 times a negative 21 is a negative 8.4. I've done these calculations ahead of time. Feel free to double check me though. All right, now I just need to add the 118 to both sides. So now we have a linear model. This is a line. We have a slope. We have an intercept relating y as a function of x. So that means x is inside of the function. All right, now let's actually interpret what the parts mean. So what does the slope mean in the context of this problem? Our slope is 0.4. What does that even mean? How is it related to blood pressure and age? So one thing to remember, so I'll put a little note here that says remember. Slope is change in y over change in x. Okay, so what does that mean for our problem? Well, y is blood pressure and x is age in years. So the slope, maybe I'll put it equal here. The slope is the change in blood pressure over the change in age. So 0.4 represents how much the blood pressure changes based on the age. Okay. Another thing to notice, 0.4 is positive, not negative. So that means our function is increasing. So let's construct a sentence out of all that information. We can say, let's start with the slope. The slope is 0.4. Doesn't have any units or anything. Okay, so we can say the average increase, because our slope is positive, so we're going to use the word increase, in blood pressure for adults is 0.4 we're just going to use our units, blood pressure units per year in age. All right, so that's what we have here, right? Change in y. So this is our y, this is our x. So y per x. So important parts. Our slope is an increase. Our function is the blood pressure, so it's the increase in blood pressure. And then we have our y over our x. All right, so you'll have a lot of practice of constructing these sentences. Okay, and then part C, we want to use the model to estimate the systolic blood pressure for a 55-year-old, round to the nearest whole unit. So what can we use to talk about the blood pressure? Let's go back to our variables. What variable do we use to represent blood pressure? We'll use y. Y represents blood pressure. Okay, so we're going to use y to do this. Also, it says for a 55-year-old, what are we using for years here? We're using x for years. So we just want to find y when x is 55. I'll write a note here. This is our x. This is our y. We can find y of 55 using this. $131.6 is my answer. It says round to the nearest whole number. So I want us to get in the practice of not just writing numbers as our answer, but actually saying what the numbers mean and giving us context. So I can read this answer and know exactly what we're talking about. All right. So maybe we can say from the sample in our chart, which is where these numbers came from, the estimated blood pressure for a 55-year-old is, we're going to round to the nearest whole number, so 132 blood pressure units. I'm pretty sure it's like, I don't know, I don't want to guess and be wrong. Okay. All right, so can you use the point slope formula? Are you able to construct a linear equation from a written description? If not, make sure you ask me questions about this in class.